Take a look at practice question set number 3 in preparation for our quiz number 3 on Monday. This is concept 14, which is force versus time graphs. I'll remind you that whenever we see a force versus time graph, every single time, no matter what you're looking for, what are you going to do? What are you thinking? What are the 3 words that come to your mind? Yep, Daniel? Area equals impulse. Good. Area equals impulse. Now, sometimes you got to do something else in addition to that, not always, but sometimes in addition to area equals impulse, what else are we going to do? Yep. Yeah, we could find the velocity. Find the velocity using mass. Yeah, okay. What equation would we use in addition to area equals impulse in order to find the velocity or the mass or whatever? Good. Delta P is equal to m times delta V. Which equation are we never going to use in the context of a force versus time graph, right? We can use it in other contexts, but just not in this context. Good. Don't ever try F times T. Even if it looks like it fits, even if it looks like it's going to get you the answer, just don't do it. Just don't go there, okay? Because 9 times out of 10 or more, it's going to lead you to a mistake, okay? Even when you think you might have the right answer. All right, let's take a look at question number 1. On practice question set number 3 now. We see a force versus time graph. Good. We expected that because, of course, that's what all of these questions are on. We're going to write down, just as a little reminder, the area is equal to the impulse. Now, after we've noticed that, after we've written that down, area equals impulse, we're going to take a look at the axes of our graph. We know it's force and time. We're going to take a look at the axes of our graph just to make sure that we have our standard units. And if we don't have our standard units, then we're going to draw attention to that, right? On our x-axis, seconds, good. On our y-axis, it's, times 10 to the 2 newtons. So we're going to draw attention to that. Okay, we see that, I don't know, I'd say about 50% of the time, about half the time, that we see units other than our standard units, and we have to draw attention to that so that we don't mess up on that when we calculate the area. All right, question number 1 doesn't require a calculation. It just says the area under the curve. Now, if this was below the x-axis, then we would say the area above the curve, right? It's always the area between the curve or the line and the x-axis. This one, the area under the curve or between this line and the x-axis represents the what? Boy, we got to get this one, right? We have to get this one. We just wrote down area equals impulse. That's the thing that always comes to our mind. This is a question where on a test, a quiz or a test, or an exam, we want 100% of you guys to get this one right. Nobody get this question wrong. All right, question number 2 asks you for the impulse experienced by the car from 2 seconds to 5 seconds. Okay, what do you got to watch out for here? Besides the times 10 to the 2 newtons on the y-axis. Yep, Daniel? Yeah, it's from 2 to 5 seconds. Like, that is dirty. Like, to put that one in there. I don't know about you guys, but when I see this, I see, the impulse, I know area equals impulse, right? So what do? I automatically just go up and find the area of the whole thing. But in this question, clearly, they're not asking for the area of the whole thing. They're only asking for the area of section 2 and section 3, from 2 to 5 seconds. So we can do that. In fact, it makes it easier, right? Because there's one less calculation to do. But it's only easier if we catch what they're asking, okay? We used to have a teacher here years and years ago, longer ago than you were even alive, that used to write a thing on the board. Okay, and I don't write it on the board, but I steal it from him sometimes. He would say RTQ, ATQ. That was what he would write on the board. RTQ, ATQ. RTQ meant read the question. And ATQ meant answer the question. Okay, read the question. What does the question ask for here? The impulse from 2 to 5 seconds. Not the impulse, but the impulse from 2 to 5 seconds. And then answer that. Okay, don't give me the total impulse. Give me the impulse from 2 to 5 seconds. All right, to do that, we've got to find this area. The area of section 2 is base times height. The base goes from 2 to 4 seconds, so the base would be 2 seconds. The height would go from 0 to 20, so we'd say 20 there, right? Times 10 to the 2. Now, notice what I've done there. Like, you could say 2,000. That's 20 times 10 to the 2, right? Or I can just say 20 times 10 to the 2. Is that okay? Yeah, that's not scientific notation, is it? 2 times 10 to the 3 would be scientific notation. Because scientific notation is always one digit, then a decimal. But who cares? Who cares what notation it is? It's still the correct number, right? I just avoided moving the decimal place over when I did it that way. When I do that, I get 4,000. That's Newton seconds. And now area 2 is equal to 1/2 base times height, because it's a triangle. Base is 1, goes from 4 to 5, and the height, once again, is 20 times 10 to the 2. I don't forget to add that 10 to the 2, because like one of the first things I did when I read this question was I took a look at my axes. Okay, and I paid special attention. Is this the 50% of the time when it's standard units, or is it the 50% of the time when it's non-standard? And I saw that it was non-standard, and I circled it as a result of that. By the way, for A2, you end up getting 1,000 Newton seconds. So what's the total impulse going to be from 2 to 5 seconds? 5,000, or 5 times 10 to the 3. I use Newton seconds. They use kilograms meters per second. Is there a difference? No. No difference. Okay, and finally we flip over the page here, and we get numeric response question number 1. Based on the graph above, if the low-friction laboratory cart starts from rest, we have a force versus time graph here, right? So because of that, we're thinking area, once again, is equal to the impulse. Starts from rest, okay, starts from rest. The final speed of the laboratory cart at the end of 8 times 10 to the negative 1 seconds, expressed in scientific notation, is what? All right, so area is equal to impulse. We know we're going to find the area of this, right? Okay, let's just do it. Okay, let's not worry about what we're looking for right now. Let's just get the area. Now, there is, of course, we do want to look at our axes of the graph before we really, I should have done that before I even read the question, right? Saw my force versus time graph. I should have looked at my axes before I even read the question. But before I go, I didn't. Before I go any further, I want to take a look at the axes. Notice that it's 10 to the minus 1 seconds and 10 to the minus 1 newtons. Both of those are, well, I say non-standard, but it's still newtons and seconds. We just have a prefix in front of them, right? Times 10 to the something. All right. One more thing, though, that I want to notice that could lead me to a silly mistake here. What is it? Yeah? Yeah, it doesn't start at 0. Okay, that's a little thing, and like it's probably not going to lead us to a mistake, but okay, if we're careless, it might. So I'm gonna draw attention to that. Okay, the things that I draw attention to avoid silly mistakes might not be exactly the same as what you draw attention to. Okay, when I do this, I'm not suggesting that everything that I circle are the only things that you should circle, or that you should circle everything that I circle, right? Like you want to draw attention to, using a highlighter or a red pen or something, things that might lead you to a silly mistake, okay? And I just circle that because, well, you never know. It might lead me to a mistake here. Okay, let's get that area here. The area, it's nice that it's just a simple triangle, 1/2 base times height. The base of this is where we got to be careful here. The base goes from, what is it? Does this go up by 0.2 or 0.4, each of those little blocks? Yeah, those are 0.2s, right? So this is going to be 0. Looks like 0.4. It's hard to tell there on this. Could you guys see it better on yours? Is it 0.4? You said 0.5? Okay, what I can do is promise you that on an exam it'll be clear. Okay, this is just, this is copied and pasted from a document, and then it's published onto this smart notebook software and so on. So you lose a little bit of resolution, every time you do something like that. I can promise you on an exam it'll be very clear whether it's supposed to be 0.2 or 0.4. Now, when I did my answer key yesterday, I said it was 0.4. If you guys could see it better on your screen and say it's 0.5, then we'll use 0.5. From 0.5 to, that's pretty clear, to 8, right? So that's going to be a base of 7.5. Now, I'm going to caution you firstly, pay attention to, whether it's 0.4 or 0.5. That's a big deal. Okay, it's hard to tell here, but usually it shouldn't be hard to tell, okay, if the resolution is better. In addition, I'll caution you to make sure you look at specifically at what the intervals are on the bottom, right? Do they go up by 0.1 or 0.2? I've seen questions before, and this is kind of dirty too, where the x-axis goes up by 0.2 and the y-axis goes up by 0.4 or 0.1 and 0.2. Or bottom line is they go up by different amounts. In fact, I think this is one of those questions, I think, where they go up by different amounts. So just watch out for that. Okay, what's our height? Looks like our height goes up to here. Okay, what does each of the y intervals go up by? Looks like 0.1, so that looks like 3.4, isn't it? Is that good? No, it isn't, is it? Yeah, we could say 0.75 or 0.34, or we could just say times 10 to the minus 1, right? Okay, whatever works for you. Now, I got to pull out my calculator because I use different numbers, a different number right here when I did my answer key. We get 0.5 times 0.75 times 0.34 gives me 0.1275. There's my impulse, right? Well, what am I looking for? My final speed. What's the initial speed? 0. Watch that, though. If the initial speed is something, then you're going to get the change in speed, but then you're going to have to do something with that change in speed. If I want to get the change in speed here, I'm going to set the impulse that I just found equal to m times delta v. Never going to use f times t, right? Delta v is equal to delta p over m, which is 0.1275, the unrounded number, divided by my mass. What was my mass? 0.50 kilograms. That would be 500 grams, or 0.50 kilograms. What does that work out to be? 2.5, I don't know, what is it? Is it 0.255? 0.255? 0.255, which, now take a look at the way they want this expressed. This might be new for some of you. A decimal b times 10 to the negative c, what the heck is that? Well, let's put this in scientific notation, right? 2.55 times 10 to the negative 1. Well, they want the value of A, B, and C. This would be, A would be what? 2, B would be 6, right? Because the next digit is a 5. I don't care if there's 14 digits after that. Look at the next digit, and then either round up or down as a result of it being 5 or lower. So this becomes 2.6 times 10 to the negative 1, or 261. And by the way, if on a test, well, you will on a test have 4 blocks to fill in. Okay, we fill in the 261 always starting on the left. If we leave anything blank, it's going to be the box on the right. Got it?